Okay, so we've learned about congruent triangles. We learned about side, angle, side, angle, side, angle, side, side, side. We've learned how to write congruency statements and what those mean. So now what we're going to do is apply something we talked about earlier in the year, proofs, to these congruent triangles. Or in other words, what we're trying to do here is we're going to take two triangles and find a way to prove they are congruent using stuff we've learned in this unit, but also stuff we've learned in previous units. And that's one thing you'll find is a lot of this stuff will build on each other. So we're going to have to reach back and remember some things we did earlier in the year. So this one here, we have a diagram with two triangles, and it says to complete the proof. And we need to show that triangle HIJ, that's the triangle on the left, is congruent to triangle JKH, which is the one on the right. The good news is they give us some information to start with. And we can see that in the diagram. We can also see that up here. So that's what you want to do. Just a reminder of how proofs usually start. You start with the stuff they already provide to you. So these first two steps will be pretty simple. We're just rewriting the stuff in the given. So we're going to say segment HI or side HI is congruent to side JK. And we can see that in the diagram too, HI, JK. They both have one little hash mark showing they're congruent. The second step is just going to be the other two sides that we know are congruent. IJ is congruent to KH. All right, so both those things are given. Both of those things are marked on the diagram. And that gives us two pairs of congruent sides. So from what we've already learned, we know to show these triangles congruent, we either need to get a third pair of congruent sides or we need to get a pair of angles. So what we're going to do is just look at this proof is the reasons are already written for us. We're going to look at the reasons and see if we can match our next step to the reason they give us. So the reason they give us for the third step is reflexive property of congruence. And we know that that means that anything is congruent to itself. So we look at the diagram. Is there some part of these triangles that is part of both triangles? And what we've got here in the middle is this line segment JH or HJ, and it's part of both triangles, and it has to be congruent to itself because of the reflexive property. So what we would say is, and what I'm going to do here, you don't necessarily have to always do it this way, but to be consistent with the congruency statement, I'm going to say JH is congruent to HJ. And the reason I wrote those in a different order, because with line segments, the order doesn't really matter. It's the same segment either way, is because on the first triangle, the way it's written up here, the J is third and the H is first. So I write J and then H. The way the second triangle is written, the H is here and then the J is first. So HJ. And that may seem like a minor thing, and it really is, but I just wanted to be clear why I was doing it that way. So we have two pairs of sides that were given to us. We have a third pair of sides in the middle, the side that's congruent to itself because of reflexive property. And the last thing is our conclusion. And our conclusion is what we are trying to prove. And what we are trying to prove is this right here. We're trying to show triangle HIJ is congruent to triangle JKH. And we know it has to be because of the side, side, side theorem. They call this a postulate. That's another word that we use to describe rules in geometry. And there's some technicalities over whether you call this a theorem or a postulate. I like to call it a theorem personally, but you will also see that word postulate. And we can get into the differences in those two words later on. But the point here is these two triangles are congruent by side, side, side. And we have shown that by writing out these steps. So let's look at another one. Here we have a lot more blank space we have to fill in because we've got two missing steps, but we also have four missing reasons. So we got to do a little bit more work. So we have a diagram here, and it tells us that angle G is congruent to angle L. So I'm going to go ahead and mark those on the diagram. And I would say, and this was true of the last time we did proofs, if you have a diagram and nothing is marked on it, start marking stuff. If you don't have a diagram at all, draw a diagram so you can mark stuff, because it's a good way to keep track of what you know. It also says GK is congruent to LK. So that looks like this segment and this segment. So that's what we're starting off with, and that's a lot to work with. So our first step, it mentions that first thing that's given. G is congruent to L, and so that's given to us. So we're going to start off with given. And we have one other piece of information that's given here. So that's what we're going to make our second step. You want to get all the given information first before you start moving on to other things. So we have GK is congruent to LK. That's given. And that's already marked, so we're good there. All right, so we have another step and two more reasons to fill in. We know where we're going. We're trying to prove that these two triangles are congruent. And we need one more piece of information to do that. So right now we have a pair of angles and a pair of sides. So there's two ways we can do this. We could find another pair of sides and do side angle side. Or we could find another pair of angles and do angle side angle. Well, looking at the diagram I don't really have any information about the other sides, but I do notice here in the middle, I have intersecting lines. And I know that whenever I have intersecting lines, I get vertical angles. And I know vertical angles have to be congruent. So I want you to watch carefully how I write this. So both of these angles are at point K. So we can't just say angle K, because then it's not clear what we're talking about. So you have to think way back to early in the year when we were naming angles. We've got to name them with 3 letters. So this angle right here, I'm going to call this GKJ, because if you go from G to K to J, it makes that angle. So angle GKJ is congruent to, and then I'm going to do the other angle, and that'll be LKH. Start from L, go to K, go to H, and it'll make that angle. It's congruent to LKH. So think back to when we were naming angles, and whenever you have two angles that are at the same meet at the same point, you'll need to name them with all 3 letters so it's clear which one you're talking about. And like we said, the reason we know that is a vertical angle theorem. Or you can just write vertical angles. I think that's sufficient here. We know vertical angles are congruent. Okay, our final thing is what we're trying to prove. The two triangles are congruent. We need a reason for that. How do we know that? Well, we've got a pair of angles and a pair of sides that were given to us, and then we found another pair of angles. So we have angle, side, angle. And you can write angle side angle theorem or angle side angle postulate, but angle side angle is enough by itself for these. I think that it's clear what you're talking about. All right, let's do one more. And we did one where we didn't have any of the steps, but we had all the reasons. We did one where we were missing a couple of the steps, and we had to fill in those and the reasons. Here we have 6 steps, which is more than the other ones. It's a little more complicated, and we have none of the reasons. So we got a lot of work to do on the right side of this. And this is also going to get into some stuff that we haven't really mixed in with triangles yet. So follow closely with this and think back to some of the vocabulary you've learned earlier in the year or maybe even in earlier classes. So the first thing given to us, it says AC bisects angle BCD. So I'm going to write that as given. If it lets me write it as given. There we go. I'm going to write that as given. It's given to us. But before we move on, I just want to make sure it's clear what that's talking about. Angle BCD is this angle right here. It's this big angle right here. And bisect, as you recall, means to cut something into 2 equal parts. So this angle BCD is cut in half by side AC, or by line segment AC. So right here, this line segment cuts this into 2 equal parts, and what that means is that this angle has to be congruent to this angle. All right, that's actually our next step. It says BCA, that's this angle, is congruent to DCA, which is this angle. And the reason we're going to give for that is, and remember from when we did proofs before, a lot of times your reasons are definitions. We're going to say definition and I'll write def period to abbreviate that, of bisector. Because a bisector is something that cuts something else into two equal parts. So if AC is a bisector, it's going to cut our angle into two angles that are exactly the same. So that's how we know that. All right, step 3, it says AC bisects BAD. That's our second given. And what's happening here is the exact same thing, just on the other side of the diagram. BAD is this big angle on the left. Line segment AC cuts that into two equal parts. And we're going to use the same reason. So again, like we did before on proofs, you'll notice some of these proofs will have a lot of repetition. You'll use the same reasons repeatedly because you're trying to just show the same thing in different parts of the diagram. So we're going to say definition of bisector again. We know if AC is a bisector, that it has to make two angles that are exactly the same, that are congruent. I've got to come up with a faster way to fix my errors. But definition of bisector is our reason for number 4. Okay, now what we have now, just so we're clear, because we're trying to prove two triangles congruent, so we got to look at the information we know. Well, we have two pairs of congruent angles. We have these two over here are congruent. These two over here are congruent. So we have two angles. And the only way we're going to get two congruent triangles, if we have two angles, is to get a side. We've got to have a congruent side. And that's our next step. It says AC is congruent to AC. AC is congruent to itself. Well, the reason for that, and this is something we've dealt with already, is reflexive property. Anything is congruent to itself according to reflexive property. All right, and now we've got a side. So now we have two angles and we have a side. So our last step here is to reach our conclusion, what we're trying to prove, that these two triangles are congruent, and we know they are because of angle, side, angle. So that's how these are going to work. So again, use the stuff that we've learned in this unit. Use your reflexive property and your angle, side, angle, side, angle, side, 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 side. But also think back to other things we've learned already. Think about vertical angles. Think about bisected angles or bisected segments. Things like that. Because those things will be tools you can use to do proofs with triangles and with other things that we come across later in the